Hello students, and welcome to this lesson over solving cube root and cubic equations. Our objective today is that we will apply our knowledge of square roots and quadratic equations to solve cube roots and cubic equations using our journal notes and practice problems. So one important thing to remember before we get started is the knowledge that the cube root and the cube are inverses. So just like when we had our square root of x and our x squared, we see that if we take the square root of x squared, we just get x, and if we square the square root of x, we just get x. So this means that these are going to be inverse operations. So just like that, our cube and our cube root work the same way. So if we have x cubed and cube root of x, we have to remember that these are going to be inverse operations. So if we take the cube root of x cubed, that's going to be x, and then my cube root of x cubed will equal x. So that's the most important thing here, is to remember that cube root is the exponent which undoes cubed. All right, so let's go ahead and look at example 1. So we know that the cube root of x is equal to 5. So we want to get x by itself. So we need to follow our SAD MEP. And remember, when we're doing our exponents here, we also are doing our radicals. So it's a little bit of SAD MERP here. So exponents and radicals are in that same step. So what we'll see is that we have a radical here, right? We have this cube root, and I want to get rid of the cube root. Well, we saw how to get rid of our cube root over here. So we had to cube that side. So I have to cube this side to get rid of the cube root. And then anything I do to one side must also be done entirely to the other. So now we have 5 cubed. So now we have the cube root and the cube canceling, and you're left with x is equal to, and now I'm taking 5 to the third power. So 5 times 5 is 25, times 5 will be 125. So that's our answer here. All right, so again, for problem 2, we're going to go through our order of operations for solving, because we're solving for our variable. All right, so first off, we have to look for subtraction. Is there any subtraction that we can undo? And the answer here is yes. So we can add 4 to both sides, and that will undo our subtraction. Now, why am I only doing the subtraction that is right here at the 4 and not the subtraction that's right here? Well, the answer is because, as we know, this radical here covers, it's a roof over this -1. So this is actually in a parentheses. So anything in a radical acts like it's in parentheses. So that's why we're doing the -4 and not worrying about that -1 yet. So we add 4 to both sides, and what we get is 4, and on this side we have the cube root of 13a minus 1. And so now we need to look down. So we've gone through our s, so we can cross that out. We're looking for any addition that we have. I don't see any addition, so we've taken care of our subtraction. I don't see any addition. I don't see any division. I don't see any multiplication that is outside the radical, right, outside my parentheses. And now we're to my exponents or radicals, right? So now I see that I've got my cube root here. So again, we want to cube both sides to get rid of that cube root. And what we'll see is that these two items here will cancel. So this cube root and this cube will cancel, and we get 13a minus 1 is equal to 4 cubed, and 4 cubed is going to be 64. So 4 times 4 is 16, 16 times 4 is 64. And now we have this nice linear expression here. So now that we've gone through our radicals, right, our radicals, we're down to the level where we had our parentheses here. So this came straight down here, and now that's in our parentheses. So now we go through our parentheses and we break them. So now we've broken through our parentheses, we've done our exponents, and we restart again. So we've done all of our steps, in SADMAP, and now whenever we get done and there's still things to do, we restart. So now we're looking again for some subtraction. And again, here we go. We see that we've got this plus 1 here, or sorry, this minus 1. So we're going to add 1 to each side. And so now we have 13a is equal to 65. And now we are done with our subtraction again. So we've done subtraction twice now. There's no addition to do, no division. Now we're looking at multiplication. Oh, okay, so I see some multiplication right here, so I need to get rid of it. So I'll divide both sides by 13. And you get A is equal to 65 divided by 13. And what we'll actually see is that this will be A is equal to 5. All right, so nothing too crazy. This is nothing new, really. The difference is now we just have to make sure that we're using our cube when it's appropriate. Solving cubic equations will work very similarly. So let's go ahead and take a look here. So we've got SAD, MERP. Because I'm solving, right? Whenever I'm solving, I want to use this order of operations. All right, so I'm trying to get x by itself. So what's our first thing that we see? Well, I see some subtraction, but what's our problem? It's inside of my parentheses here, so I can't get to it just yet. So I'm going to ignore that for now, and I keep on going down, and it looks like the next thing that I encounter is going to be my exponents and radicals. So I have an exponent. And how am I going to get rid of this exponent? Well, I know that the inverse of my cube root, right? The inverse of my cube will be the cube root. So if I take the cube root of x cubed, then I get x. So that's what I'm going to go ahead and do to both sides. So I'm going to go ahead and take the cube root of each side. And over here, my cube and my cube root will cancel, and I'll be left with x minus 2. And that will then give me, and I have x minus 2 is equal to the cube root of 125. And this is a calculator function that you can use. But also, I just know off the top of my head that 5 times 5 times 5 will give me 125. So that's a nice cube root there. So that'll be 5. And then we get down to our parentheses, so we can go ahead and break our parentheses here and return back up to the top. So now I see x minus 2 is equal to 5, and I can go ahead and solve from here. So I see subtraction, so I'm going to use addition to get rid of it. You get x is equal to 7. All right, go ahead and take a second and see if you can solve number 4 before we go ahead and do it. I'm going to wait about 5 seconds before I go on. Go ahead and pause the video and see if you can work through number 4. Okay, so for number 4, what we're going to do is, again, we need to go through our order of operations. We're solving, so it's using SAD, MERP. Okay, so we see some addition right off the bat. So we did subtraction. There wasn't any subtraction that was outside of my parentheses, right? Then we saw that we had some addition that we needed to do. So we're going to subtract 9 from each side. And what we're going to find is that we get negative 1 over here, and you get x minus 4 cubed on the other side. And so now we're down to, we're looking for some division. There's no division. We're looking for some multiplication. There's no multiplication. And now we're down to exponents. So again, to get rid of that cube, we're going to cube root each side. And we'll find that the cube root of negative 1 is negative 1. And then the cube root of x minus 4 cubed, the cube root and the cube will cancel each other out, and you get x minus 4 is equal to negative 1. And so now we can restart, right? So we went down, we now have our parentheses, we're breaking through our parentheses, and we can restart. So now we're going back up to our new order of operations again. So x minus 4 is equal to negative 1, and we're going to add 4 to each side. and you get x is equal to 3. So solving for cube root and cubic equations, nothing really all that new. We are using a new function, the cube, but in essence it works the same way that our squares and our square rooted equations worked as well. So I know that the cube root and the cube, all of this notation is starting to get a little silly looking, right? If you've got this number outside the radical, and then you've got the radical, and then you've got your exponent, it gets really messy really fast. So what we found is that there's actually a way to write these radicals as an exponent. So let's go ahead and see what that looks like. So we have the cube root of x is equal to x to the 1/3 power. Interesting. So what this means is that now I have a way of expressing radicals as an exponent. That's why radicals and exponents are actually done together in that same step, is because they're actually different expressions of the same idea. So now I know that the cube root of x is the same thing as x to the 1/3 power. And that lets me do all kinds of really nice things with my notation. So for instance, here's something that we could do. Let's say that I have the cube root of x squared. I can rewrite this as x to the 2/3 power. So my whole number exponent is now written over the fraction. And we'll find that this is the way that our rationals are going to work from now on. So our exponents will always work in this way. So go ahead and see if you can determine, if I just gave you the 4th root of x cubed, what do you think the power will be? And what we find is that it's going to be x is equal to, the 4th root of x cubed would be equal to x to the 3/4 power. So it's an exponent of 3/4. All right, so let's see this and see how it makes our problems look a little bit nicer and are a little bit more reasonable to solve. All right, so for our first problem, we've just set it up where we already have 2x plus 1 to the 1/3 power is equal to 1. So now, when we write SADMAP, we don't even have to remember the fact that radicals go in the same place as the exponents. So now radicals are naturally in the same place as an exponent, so we don't even have to worry about that notation. So now, if I want to get rid of this 1/3, right, we know that if I take the exponent x times 2, right, or x to the 2nd power, if I want to eliminate that power, or let's just go through the multiplication of it, right? So x squared to the 2nd power would equal to x to the 4th. So we multiply the exponents. So one way that we can express the fact that x squared and x square root is going to be inverses is we can say x squared to the 1/2 power is equal to x. And the same thing will work here. So if I want to get rid of this exponent, I take the entire thing to the exponent of 3. So I cube both sides again. And we see that 2x plus 1 is equal to 1, because 1 cubed is 1. So then we subtract 1 from each side, and we get 2x is equal to 0, and x is equal to 0. All right, so let's see where it's a little bit more helpful to us. So in example 6, first looking at it, I see at least 3 steps that we need to take to do this problem, right? 4 steps. We need to add 4 to both sides, and then we need to cube both sides, and then we need to square root both sides, and then we would have to add 2 to both sides again. So instead, let's go ahead and rewrite this with our new notation. So instead of writing this as the cube root of x minus 2 squared, we'll write this as x minus 2 to the 2/3 power minus 4 is equal to 5. All right, so then we just add 4 to both sides, and you get 1 is equal to x minus 2 to the 2/3 power, And so what we're going to want to do is take this all to the 3 over 2 power, because our whole goal is to get rid of this fraction up here. All right, so we have x minus 2 is equal to, and we're going to take this side to the 3 over 2 power, and luckily for us, 1 to the 3 over 2, the square root of 1 is 1, and then to the power will be 1 as well. So 1 to the 3rd power will be 1, and then the square root of 1 will also be 1. So this will be 1 here. And so you get x is equal to 3. All right, so for your assignment, what we want to do today is first write a reflection over what you learned today and how you feel like you understand it. So that would be about a 2-sentence reflection, and then once you're done with that reflection, ask me to come around and I'll give you a stamp for your reflection, and then what we need to do is get started on our assignment, which will be 10-4, solving cube root equations. All right, have a wonderful day, and I will answer any questions that you have in class. Goodbye.